name is Nicholas Liu Wei Hong. I'm from J1D and my seat number is 38. I'm the leader of the mathematics project.
Hi, my name is Nixon Liu Yanchert. I'm from J1D and my seat number is 39.
Hi, my name is Clement Siu Yin Heng. I'm from J1D and my seat number is 11.
What is percentage? In mathematics, a percentage is a number of or ratio expressed as a fraction of 100. It is often denoted using the percent sign, although the abbreviation PCT and sometimes PC are also used. A percentage is a dimensionless number, pure number. It has no unit of measurement.
1% means 1 per 100. For example, 45% read as 45% is equal to the fraction 45 over 100. The ratio 45 to 55 or 45 to 100 when comparing to the total rather than the other portion, or 0.45. Percentages are often used to express a proportionate part of a total. Similarly, one can also express a number as a fraction of 1,000 using the term per mile or the symbol.
The most basic application of percentages is to compare one quantity against another. With the second quantity rebased to 100, let's say we are interested in the number of employed females as percentage of all employed. If this fraction is 1 over 2, it means in general, for every 2 employed person, 1 is a female.
Example 1. Calculate 25% of 80. The solution is 80 times 25 over 100. And you will find the answer is 20%. Example 2. Calculate 30% of 70. The solution is 70 times 30 over 100, and the answer is 21%. Example 3. Calculate 10% of 30. The solution is 30 times 10 over 100, and you will find the answer is 3%.
Example 4. 15% of 200 apples are bad. How many apples are bad? The solution is bad apples equal 200 times 15% equal 200 times 15 over 100 equal 30%. Example 5. Out of 55 students in class A, 18 of them are wearing spectacles. Find the percentage of students who are not wearing spectacles. The solution is students that didn't wear spectacles equals 45 minus 18 over 45 times 100% equals 27 over 45 times 100% equal 60%.
Example 6. A shopkeeper bought 600 oranges and 400 bananas. He found 15% of oranges and 8% of bananas were rotten. Find the percentage of fruits in good condition. Solution. Number of rotten oranges, 15% of 600 equals 15 over 100 times 600 equals 9,000 over 100 equals 90. Number of rotten bananas equals 8% of 400 equals to 8 over 100 times 400 equals to 3,200 over 100 equals to 32. So the percentage of fruits in good condition equals to 600 plus 400 minus 90 plus 32 over 1000% equals to 1000 minus 90 plus 32 over 1000% equals to 878 over 1000 times 100%. So the answer is 87.8%.
The general rule for finding a given percentage of a given whole is work out the value of 1%, then multiply it by the percentage you need to find. This is the easiest to understand with an example. Let's suppose that you bought 200 apples. 10 of the apples are bad. How many percent is the bad apple? As a fraction, 10 over 200 equals to 0.5. As a percentage, it is 10 over 200 times 10 times 100% equals to 5%. The conclusion is 5% of those apples are bad.
Thanks for watching.
Hello everyone, my name is Wilnibel Kwetzen Hui from class J1H. Today, I'm going to show you a really simple way to multiply two numbers together. This technique is from Japan and it involves substituting numbers for lines. We'll start with 13 times 21. As we can see, the first number is 1, which means we draw a straight line. The next number is 3, so we leave a little space and draw 3 lines. After that is number 2. Draw 2 lines in the other direction. Leave a little bit of space, and as for 1, draw a straight line. Once we drawn it out, we need to separate it into 3 separate zones where the lines cross like this. Starting from the right hand zone, we need to count how many lines crossed. In this case, 3. We write that here and move to the next zone. Again, we count how many lines crossed and write it on the top. Move to the last zone and do the exactly same again. 2, 7, 3. So 13 times 21 equals 273. Here's another quick example. 32 times 12. The first number is 3. Draw 3 lines, leave some space, and draw the next number, 2 lines. Draw 1 line in another direction, leave space, and draw 2 lines. We mark out 3 zones again. Starting from the right zone, count the lines. 4, 8. So write down that here. And finally, 3. 384. There we have our answer. 32 times 12 equals 384. Simple. I hope you find this video helpful. Again, this is the simple way to multiply two numbers together. Thank you for watching.
Hey guys, welcome to our presentation about symbols that we use in our daily lives. Joining me today, we have the genius in our group, Sean Gong.
Hello guys, my name is Sean.
Next up, we have Yuri Lee.
Hope you guys will enjoy this presentation by us.
Lastly, me, the group leader, Tikai Sheng. Starting off, let's pass it on to Yuri to explain the basics of the symbols in maths.
First of all,
we are going to learn the basics in the calculation of math equations, plus and minus. These are the most common and frequently used symbols in math equations. Plus means add while minus means subtract. Here's an example. 5 plus 5 equals to 10. As you can see, 5 dots plus 5 dots become 10 dots. Now for an example of minus. 10 minus 5 equals to 5. This means that you are taking away 5 from 10. Now we get into multiplication. This is one of the basics in the operation of arithmetics. It is basically repeated addition. Multiplication is represented by 3 symbols. In example 1, 3 times 5 equals to 15. These 5s represents the 3 in the first equation. Same goes for example 2. Division. This is also one of the basics in the operation of arithmetics. Unlike multiplication, division is repeated subtraction. Division is represented by this symbol. In example 1, 20 divided by 5 equals to 4. But how do we get the answer 4? We keep subtracting 5 from 20 until it becomes 0. The amount of times of subtracting is the answer. This goes for example 2 as well. Now, I'll let Sean continue. Thank you.
Hello everyone, so today I'm going to talk about 3 symbols that we use in our daily lives. So the first symbol I'm going to talk about is the not equal to symbol. This symbol is a sign of inequality. It is used to show a comparison between 2 quantities which are unequal. I have an example here. 3 plus 2 and 4 plus 2. As we know, 3 plus 2 equals 5 and 4 plus 2 equals 6. 5 isn't equal to 6, therefore 3 plus 2 is not equal to 4 plus 2. Moving on, we have fraction. A fraction represents a part of a whole, or more generally, any number of equal parts. To sum it up, a fraction describes how many parts of a certain size. Now, fraction is made up of 2 integers, one on the top and one on the bottom. The one on the top is called a numerator, while the bottom one is called a denominator. These 2 numbers are separated by a line. I have 2 questions here. To solve it, first we have to find the denominator. There are 1, 2, 3 and 4 of them. In the numerator, there is one red colored shape here. So we'll get 1 over 4. 4 being the total amount of parts forming a circle, and 1 is the red colored part. This same goes for the second question here. There are 6 total boxes in this rectangle, and 4 of them are colored. So we'll get 4 over 6. Moving on to the last topic, square root. The square root of a number is when it is multiplied by itself. For example, 4 times 4 equals 16, so the square root of 16 is 4. Do note that negative 4 times negative 4 equals negative 16 too. So negative 4 is also a square root of 16. I have an example here. To solve this question, we first need to find 1 times 1 equals 75. I found out that 25 times 3 equals 75. And 25 can be found in 5 times 5. This can also be written as 5 to the power 2. 5 to the power 2 times 3. So now, to cut off with square root, we'll get 5 square root 3. And that is all. Thank you very much.
Now moving on to me. First of all, we are going to talk about percent. The percent sign is a symbol used to indicate a percentage, a number or ratio as a fraction of 100. Here's an example question. Aaron had $2,100 left after spending 30% of the money he took for shopping. How much money did he take along with him? So to solve this question, we need to know how much is 100% of Aaron's money. To do so, we use 100% times $2,100 and divide it by 70%. Since it's stated that Aaron spent 30% of the money, meaning that Aaron now has 70% of the money that he started with, and so the answer is $3,000. Next up, inequality. Here is 4 symbols of inequality. First, this symbol is the greater than symbol. This symbol means the number that is after this symbol is smaller than the number that is in front of the symbol. And here you can see an example. Next, the is less than symbol. The symbol is the other way around. This symbol means that the number that is after this symbol is bigger than the number that is in front of the symbol. After that, the is greater than or equal to symbol. This symbol is the same as the is greater than symbol, but it can be equal to the number as well. And lastly, the is less than or equal to symbol. It is also just like the is less than symbol, but also can be equal to the number. And that's it from me. And that's it for today. Thank you all for listening.
We hope you guys learned something from this presentation.
See you next time.
Goodbye.
老师你好，我是来自初二里班41号的 Trophy。今天我要讲的是 Chapter 4.2 about exterior and interior angle 的2个 triangle 的 question。Find the value of x, y and z in the following， 就是要找 x, y 还有 z， 所以可以先找 x 先 ，x 就是这边。所以 x 等于64度加20度等于84度，就是这边64度、20度，然后这一边是 x。接下来可以找 y 就是这边 y 等于36度，再加64度等于100度。y 是这边64度、36度，然后这边是 y， 然后到最后是可以找 z 等于100度。因为知道 y 是100了，所以就可以直接写100度加20度等于120度，所以就是这样，100度，这边就是20度，然后这边就是 z， 所以 x 的答案就是84度 ，y 的答案就是100度 ，z 的答案就是120度。然后第二题也是要一样。Find the value of x in the following， 就是要找 x， 然后这一边的一半是180度。现在要找这个 a 等于180度减133度，就是等于47度。a 是等于47度。然后现在是要找 x， 所以这边47度再加 x 等于85度，所以 x 等于85度减47度等于38度，就是这样。47度，然后这边是 x， 这一边是85度， 所以 x 的答案就是38度。So 今天我要讲的2个 triangle 的 question 就到这边。老师再见。
Dear all, I am Tsin of Junior 2 Tshung. Today I am going to share some thought on the very important and prominent next concept, Pythagoras theorem. To understand it, all you need to do is to draw a right angle triangle, a triangle in which one of its angles is a right angle. What is so special about this triangle or this theorem? The first thing that you need to understand is that firstly, the side opposite the right angle is called hypotenuse. The theorem says that the hypotenuse of a right angle triangle has special relationship with the other two sides of the triangle. It tells us that the square of the hypotenuse is equal to the sum of the square of the other two sides. Remember, this is only true in the case of a right angle triangle. So now, let's prove that this area plus this area equals to this area. Assuming that A equals to 3 cm, B is 4 cm, and C equals to 5 cm. The area for the smallest square is 3 times 3, which is 9. For the middle square is 4 times 4 equals to 16. And the largest square is 5 times 5, which is 25. It is clear that the sum of the smallest and middle square is equal to the largest square. Hence, it is proven that a square plus b square equals to c square. The theorem is very important for its numerous uses. It is useful for both air and sea navigation, as it makes use of the two legs forming a right angle triangle to find the shortest diagonal distance. It is also used in the same manner for architecture, construction, and survey. Thank you for watching.
老师好，我是初32班的杨宇轩，是18号。今天我要讲解 quadratic factorization。现在我们进入我们的下一个 slide。这就是我们平时看到的 quadratic equation， consist of 一个 x square， 一个 x， 还有一个 normal digit。而这就是一个 factorized version of the equation， 分成了2个括弧。我们可以找到这样子的这个 equation by doing cross multiplication。我们会用这3种不同的 shape 来找出我们要的答案。分别是一个 small square 1乘1等于1，一个 rectangle 1乘 x 等于 x， 还有一个 bigger 的 square x 乘 x 等于 x square。我们都知道 rectangle 的 area 是用 a 乘 b 找出来的，所以 x square 加 3x 加2，我们就把这些 component 全部 transfer 成一种 shape。我们有一个 x square， 3个 x。2个1，我们把这些刚才所mention的 shape 全部排列起来，就变成一个 rectangle， 然后我们从它的 side 找我们要的答案。consist of x 加1加1等于 x 加2和 x 加1。这就是我们的 area x 加1括弧 x 加2括弧。现在 example 2。我们也是一样，把全部这些 component transfer 过来变成一种 shape。我们有2个 x square， 5个 x， 还有2个1。2x square 加 5x 加2，也就等于我们把这些全部 component 列出来，变成一个更大的 triangle。所以我们要的答案也是从旁边拿出来。2x 加1 x 加2。这就是我们的 area 2x 加1括弧 x 加2。今天我的 sharing 就做到这里，谢谢。
Hi, I'm Uma.
Hi, I'm Wayne.
Hi, I'm Justin.
And I'm Amber.
Today, we'll be elaborating on undefined and unique numbers. First and foremost, we will be touching on the concept and meaning of infinity. Next, we will be talking about the concept and uses of pi. Last, but certainly not least, we will decipher the concept of zero and explain why a number can't be divided by it.
So what does undefined and unique numbers mean? To understand this concept, we will be breaking down the concept into undefined numbers and unique numbers separately. Unique numbers are the numbers of never-ending values or of no value. Some common examples are the pi, the Euler's number, and the golden ratio.
Undefined and unique numbers are not entirely similar, because undefined numbers are a set of numbers that are not in the domain of a function or defined for a certain number. For instance, a number divided by 0 is unspecified, so it isn't allowed and therefore undefined. We can understand why if we think about the relationship between division and multiplication.
In brief, we are going to discuss three main mathematical concepts, which are the infinity, the boundless and endless state, the pi, ratio of circumference and diameter of a circle, and the zero concept. For zero concept, a concept when operated in which it often results in undefined numbers. First of all, let's have an in-depth look at the concept of infinity, discovered by John Wallis. Infinity is something that will never end, meaning it has no boundaries. This symbol is associated with it. Humans have been sticking around with this concept for quite a long time, and usually used to define something that is larger than a real number. A common example would be black holes have a gravitational field so powerful that not even light can escape. Hence, it is said that a black hole is a region of infinite density.
We can use infinity in the application in physics. We can use it for multiple measurements and counting. For example, infinity can be used as a replacement for large numbers. Infinity can be used to make theoretical projections too. Infinity is also used in computing, arts, games, and cognitive sciences. These can be used in certain coding softwares. Here are some properties of infinity in simple arithmetic calculations. Positive and positive makes positive. Negative and negative added together makes negative infinity. In conclusion, multiplication rules applied on infinity are as what is normally done.
Moving on, the concept of pi. Any circle has a circumference over diameter of pi, hence making it a constant value that doesn't change. Babylonians were the first to discover this, and the symbol of pi was first used by William Jones in the year of 1706. The digits are infinite and are not uniform.
Through calculus, a type of math, the first few hundred digits of pi have been calculated. 3.14 and 22/7 are commonly used, as it is the closest to the actual value of pi. Pi is used in a variety of calculations, ranging from the simplest, which is calculating areas and volumes of geometrical shapes, to complex formulas, such as those involved in space. Pi has an infinite amount of non-recurring numbers. There are many formulas which involve pi. First, and one of the simplest pi formulas is calculating the volumes of cylinders, or in fact, any circular shapes. The second one is the amount of time taken for a pendulum to oscillate once. Lastly, in Kepler's third law, the pi is a constant term to find the time taken for a complete orbit of any planet.
Lastly, the concept of zero. Here are a few simple calculations involving zero. Keep in mind that zero cannot be a denominator. Division by zero is when the denominator of the fraction or the divisor is zero. In this phenomenon, the fraction is undefined. When any number is multiplied by zero, it results in zero. Using the same concept, when divided by zero, it can be any number, hence undefined. An example of zero denominator is in the programming errors. When the code written has a zero denominator, the program will return a math error. Not to mention, it will return math errors when typed into a calculator.
That's all from us today. Thank you so much for your time. Bye!
So I've invited Liana and Vanessa to play a game with me. The game is pretty simple. I'll pick a random number from 1 to 15 and they'll have to guess the number that I've chosen. However, they only have 4 guesses. Let's go with Vanessa. What do you think is my number?
I choose the number 13.
Well, the number is less than 13.
Well, the second number I chose is number 10.
It's less than 10 as well.
How about number 6?
Oh, it's less than 6 also. Last try.
Last, I choose number 4.
Yes, that's the correct answer. Now, Vanessa, I chose a number from 1 to 50. Can you guess what's the number?
I choose number 48.
Oh, it's smaller than 48.
How about number 41?
It's smaller than that too.
13?
Bigger than 13.
Not correct again. Let me choose number 16.
Oh, it's not 16 either, but it's bigger than that.
Oh no, is it number 21?
No, it's bigger than 21.
Last, I choose number 25.
Oh no, it's not 25 also. But Vanessa, would you mind telling us how you tried to guess my number?
Actually, I just simply guessed.
Oh, then lie. So, Liana, I chose a number from 1 to 15. Can you guess the number?
The number that I choose is 8.
It's less than that.
Oh, what about 4?
Yeah, that's correct. Okay, now I've chosen a number from 1 to 50. What do you think is my number?
I think it's 25.
25? It's bigger than that.
What about 58?
Yes, that's my answer. So, Liana, how did you manage to find my answers so quickly and accurately?
Actually, I use a simple formula to narrow down my choice of answers.
Whoa, what's the name of the formula?
It's called binary search. Let's ask Ning Song to explain that part.
So what is binary search? Binary search is an efficient algorithm for finding an item from a sorted list of items. It works by repeatedly dividing in half the portion of the list that could contain the item, until you've narrowed down the possible locations to just one. Just now, Liana has used this method to narrow down her choices by half each time she guesses the number. But now we have one question. How do you know exactly the maximum number of guesses for each range of numbers? This actually involves 2 math concepts that we have learned: probability and geometric sequence.
Probability is a measure of how likely an event is to occur. For example, this is a dice that contains 6 numbers. I would like to know the probability of getting even numbers in this dice, which is 2, 4, and 6. There are 6 numbers on this dice, with 3 of them being even numbers, so 1/2 will be the probability of getting an even number on this dice. Let's have a smaller number range, which is from 1 to 10. The total number of choices is 10. Using this method, you increase your probability of getting the chosen number by dividing the largest number by 2. So it would be 5. If that isn't the answer, divide number 5 by 2 again. We're doubling the probability of getting the chosen number. This process is repeated till the sample space is reduced to 1, where the probability is increased to 100%. At this point, there is no way that your answer could be wrong. When we implement binary search into this game, this is what happens. We're halving the number of possible outcomes, aka the sample space, which means we're doubling the probability of obtaining the correct answer. On the other hand, if we use the random guessing method, we're only reducing the sample space by 1 each time. This is less efficient linear search method.
Now, as you can see, the progressing probability, which is increasing, forms a geometric sequence. This is the formula of a geometric sequence. In our case of guessing between 10 numbers, the first term is 1 over 10, and the common ratio is 2, so we can substitute those numbers into the formula. Let's say we're a little unlucky, and we can only get the answer after the maximum number of guesses. When the probability of getting the correct answer is reduced to 1, to find n, we just have to shift the numbers by converting index to log. And the value of n is 4.32, which is approximately 4. Hence, the maximum number of guesses needed is 4. Now, let's take this up another level by increasing the range to 1 to 100. In this case, the first term is 1 over 100, because the probability of obtaining the correct answer at first is 1 over 100. Using the binary search method, the common ratio is 2. Doing the same thing for this part, the max number of guesses is 7.64, which is approximately 7. That is how we know the maximum number of guesses needed for each range of numbers.
Binary search is implemented in computer systems to obtain data efficiently. Imagine if we had 1,000 data stored in a computer. It'll take ages for it to obtain one data using linear search methods. That's why computers use binary search, and they are so fast at retrieving data.
大家好，我们是来自初一合班的廖嘉文，
我是何瑞芝。
感谢崇正的培育，祝贺崇正56年华诞，桃李满天下，再创辉煌。
不知不觉，崇正已经56岁了。祝崇正生日快乐，校庆快乐！我们爱崇正。
I, Mr. Tsin, am deeply honored and happy to speak on the occasion of our school's STTSS 56th anniversary. All these years, Sabah崇正Secondary School has endeavored to teach and inspire its students to build self-respect and strive for educational growth and excellence. Best wishes to all of you and us in the true spirit of Chongqing One Happy Family. 崇正一家亲。Happiest congratulations on your 56th anniversary and all the best for the school's continuous and ever progressive success. Thank you.
祝沙巴雅比崇正中学，
祝崇正中学
在此祝沙巴崇正中学
56周年快乐
！56周年生日快乐！
祝崇正中学56周年快乐！
在此祝沙巴崇正中学56周年快乐！
祝崇正中学56周年快乐！
祝沙巴崇正中学56岁生日快乐
！Hello， 我是毕业于1996年的合音点校友，我现在是在雅比沙巴这个地方，我是一名药剂师。首先，我要对母校说 Happy 56th Anniversary！ 我要谢谢当年的母校的老师们培育了我们。让我们这些小苗能够茁壮成长，让我们现在都能够做我们喜欢做的事业，而且也能够为社会出一份绵力。我在此祝我的母校校务蒸蒸日上，能够培育更多的人才。崇正的校友一代比一代好，而且我们崇正将永远以我们这些毕业的校友为傲。加油哦，崇正！
Thank you, Chongqing, for 56 years of prosperity.
For 56 years of happiness.
56 years of grinding.
And for 56 years of memory.